In the world of software development where complexity reigns supreme, ensuring the delivery of high-quality software is paramount. Software testing plays a critical role in this endeavor, acting as a gatekeeper against defects and a guarantor of functionality. However, traditional testing methodologies often stumble when confronted with a pervasive challenge: unclear or poorly defined requirements. This is where reverse engineering requirements emerges as an invaluable approach. Reverse engineering requirements in software testing involves meticulously analyzing existing software artifacts to extract and understand the implicit or poorly documented requirements that underpin the system's behavior. By delving into the code, documentation, and even user interactions, testers can unearth hidden assumptions, uncover inconsistencies, and gain a deeper understanding of the system's intended functionality. This contrarian approach challenges the conventional wisdom of relying solely on upfront requirements gathering, acknowledging that requirements are often fluid, evolving entities that may not always be fully captured or communicated at the outset of a project. By embracing reverse engineering, software testers can bridge the gap between ambiguous requirements and robust testing, ultimately contributing to the delivery of higher quality software that meets the needs of its users. Reverse engineering in the context of software testing is akin to an archaeological dig. Just as archaeologists carefully excavate and examine artifacts to piece together the history of a civilization, software testers employ reverse engineering to uncover the implicit requirements and design decisions embedded within a software system. Unlike traditional software engineering, which follows a linear progression from requirements gathering to design and implementation, reverse engineering starts with the end product, the software itself, and works backwards to understand its underlying structure, behavior, and intended purpose. This process involves analyzing various software artifacts, including source code, databases, configuration files, user interfaces, and even network traffic. By scrutinizing these artifacts, testers can infer the underlying requirements that drove their creation, even if those requirements were never explicitly documented or have evolved over time. Reverse engineering in software testing is not about modifying or replicating the software. Rather, it is a process of discovery, aimed at gaining a deeper understanding of the system's true functionality and identifying potential areas of risk or improvement. Unclear requirements represent a pervasive and insidious challenge in software development, often leading to project delays, cost overruns, and ultimately, software that fails to meet user expectations. These ambiguous, incomplete, or contradictory requirements can arise from a multitude of sources, including poor communication, miscommunication between stakeholders such as business analysts, developers, and testers, can result in requirements being misinterpreted, omitted, or poorly documented. Evolving needs. As projects progress, user needs and business priorities may shift, leading to changes in requirements that are not always effectively communicated or reflected in the documentation. Technical constraints. Limitations imposed by the chosen technology stack or existing infrastructure can influence the feasibility and implementation of certain requirements, potentially leading to compromises or workarounds that are not explicitly documented. Implicit assumptions. Stakeholders may make assumptions about the system's behavior or user expectations that are not explicitly stated, leading to misunderstandings and potential defects. The consequences of unclear requirements can be significant, impacting not only the development process but also the quality and usability of the final product. Dissecting unclear requirements is essential for effective software testing. Here are practical techniques to bring clarity. Requirement analysis. Scrutinize existing documentation for inconsistencies, ambiguities, and gaps. Look for missing details, conflicting statements, and undefined terms. User story mapping. Create visual representations of user journeys and interactions with the system. This helps identify missing steps, alternative paths, and potential pain points. Scenario testing. Develop test cases based on real-world scenarios and user stories. This helps uncover implicit requirements and edge cases that may not be explicitly stated. Collaboration. Engage in frequent and open communication with stakeholders, including developers, business analysts, and end users. Ask clarifying questions, challenge assumptions, and seek consensus on the intended behavior of the system. By applying these techniques, testers can gain a clearer understanding of the system's intended behavior and identify potential areas of risk or ambiguity. Section 5. Real-world examples. Reverse engineering in action. Let's consider some real-world examples to illustrate these techniques. Example 1. E-commerce platform. Imagine testing an e-commerce platform with a poorly documented add-to-cart feature. By analyzing user interface elements, observing network requests, and examining database transactions, you discover that the system implicitly handles adding multiple quantities of the same item as separate line items in the cart. This insight allows you to design test cases that specifically target this behavior. Example 2. Financial trading system. In a financial trading system, a requirement states that the system should execute trades at the best available price. However, the term best available price is not clearly defined. Through reverse engineering involving the examination of algorithms and market data feeds, you discover that the system prioritizes execution speed over price improvement in certain market conditions. This finding prompts further discussions with stakeholders to clarify the requirement and potentially adjust the system's behavior. These examples highlight how reverse engineering helps uncover hidden assumptions and implicit requirements, leading to more comprehensive and effective testing. Section 6. The benefits of reverse engineering for software quality. Reverse engineering requirements offers numerous benefits for improving software quality. Enhanced test coverage. By uncovering hidden assumptions and implicit requirements, reverse engineering enables testers to design more comprehensive test cases that cover a wider range of scenarios, including edge cases and boundary conditions. This leads to a higher level of test coverage and a reduced likelihood of defects slipping through the cracks. Improved defect detection. Reverse engineering helps identify potential defects early in the development cycle, when they are typically less costly to fix. By understanding the system's underlying structure and behavior, testers can design targeted tests that expose vulnerabilities and inconsistencies that might otherwise go unnoticed. Reduced ambiguity and misinterpretations. By clarifying unclear requirements, reverse engineering fosters better communication and understanding among stakeholders. This reduces the likelihood of misinterpretations, assumptions, and conflicting expectations, leading to a more aligned and efficient development process. Enhanced documentation. The insights gained through reverse engineering can be used to improve the quality and completeness of existing documentation. This ensures that the documentation accurately reflects the system's actual behavior and provides a valuable resource for future development and maintenance efforts. Section 7. Overcoming challenges and reverse engineering requirements. While reverse engineering offers significant benefits, it's not without challenges. Complexity. Reverse engineering complex systems can be time-consuming and require specialized skills and tools. Lack of documentation. In some cases, documentation may be scarce or outdated, making it challenging to understand the system's original design intent. Resistance to change. Some stakeholders may resist the idea of revisiting or challenging existing requirements, even if they are unclear or incomplete. Overcoming these challenges requires a combination of technical expertise, effective communication, and a willingness to embrace a collaborative approach to software development. Section 8. Conclusion. Embracing reverse engineering for superior software. Reverse engineering requirements is a powerful tool that enables testers to overcome the challenges posed by unclear or poorly defined requirements. By delving into the intricacies of existing software artifacts, testers can unearth hidden assumptions, uncover inconsistencies, and gain a deeper understanding of the system's intended functionality. This contrarian approach to software testing empowers testers to bridge the gap between ambiguous requirements and robust testing, ultimately contributing to the delivery of higher quality software that meets the needs of its users. By embracing reverse engineering, software development teams can foster a culture of continuous improvement, where the pursuit of clarity and understanding drives the creation of software that is not only functional, but also reliable, maintainable, and fit for purpose. Section 9. References. Feathers, Michael. Working Effectively with Legacy Code. Prentice Hall, 2004.